All right, so we took a look at several RESTful APIs that we created here to be able to interact with our JPA entity, where we're able to retrieve them by their primary key, by some query parameters, username and password, and also retrieve all of them. We also were able to post a new instance of the user by creating this RESTful service as well. So let's take a look at a couple more updates that are fully supported by the default, by the out of the box repository that JPA provides. So yeah, so this is an example of posting. You can also do updates, where the update you might parse the ID of the user and then the new data for that particular user. So the strategy is to first retrieve the object that you want to, the record, right, that you want to work with. First, retrieve it from the database. Right. Once you have it in memory, then you can change any of the properties. Right. Maybe only change the username, or only change the first name, or only change any of the fields that you want to change. Okay. Here I created a function that just changes all the fields. Right. If the fields are different, then it changes it. Okay. And then once you've changed any of the fields, you can use the repository to save back the object back into the database. Right. Notice that the first save that we looked at earlier did an insert. Okay. But in this case, a save will do an update, right? Because it's an instance that already exists in the as a record in the database. So that's why save is a smart method to know that it will do one thing or another. The other thing to point out is that the object that you get, this user object, even though it's an object that you created, it's a class that you declare, and the actual type of this object here, the actual type of this user, right, is not actually your user. Right? It's an augmented user. It's a user implementation that extends your user, right? That re-implements your API, your setters, your getters, okay? So that will proxy your setters and getters, right? Any setter that you call on that object, it will first intercept the call, and then it will proxy it to your object, right? So the reason that it intercepts it is that it wants to make sure if the object is pristine, if it's dirty, right? It wants to know if the object has changed in any way from the last time that it read it from the database. Right? It wants to know that. It wants to make sure that if it's read from the database as a record, it wants to make sure that once it's in RAM, right, that how far is it from the original instance that it read from the database. Right? If you haven't done anything to it, if you haven't changed any fields, any username, passwords, then this .save wouldn't actually do anything. There's no need to update anything, right? If the fields haven't changed at all, right? So that's why JPA gives you, right, the illusion that you're working with your original user object, but it's actually a smart. It's what's referred to as a managed object. Right, it's an object that is being managed by the framework, okay, that has the same interface, the same setters, the same getters. It looks just like your user, okay, but it's actually wrapped inside of a managed object that intercepts any communication with your object, right, to maintain, to know what the life cycle is, right, and that's where EJB failed, okay. EJB, you would have to implement all these hooks about the life cycle of the object. If it ever changed, right, you were responsible to notify the framework, hey, I changed, I'm dirty, right, I need to be synchronized with the database, right. What JPA does, right, it's a little smarter, right, it says, well, no, we'll handle the life cycle for you, right, so that it's not your responsibility, okay. So let's try this out. Notice that we're using, again, we're following the best practices in the RESTful API. Here, let's see that for changing data, we're going to use a put, right? A put mapping, because we're modifying an instance that already exists in the database. So let's import that, and we're gonna take two things from the request. One of them is the ID of the object that we want to modify, and the other thing is a parsed version of the object that we want to modify it to, right? So maybe some fields might change, some fields might not change, and so so here the strategy is to first retrieve the object from the record, from the database, and then internally either set one field or another field. Here I'm going to create a function here, a method here that's going to just change all of them, right? So here I already have it implemented. Here's a set. It's going to check to see if it's the same value. If it's the same value, it's not going to update. It's not going to touch it. Right. So here, oops, I just need the body. There. So because we could pass it a JSON object that doesn't contain all the fields. It could be that we only pass a JSON object that only has first name, right? And all the other fields then will be mapped to just null, right? If it's null, we're not going to do anything. Otherwise, we are going to copy over. There we go. Oops. All right. All right. So let's try it out. Let's start this, and let's go. Let's we can generate put from the from the browser, so we'll need to do it from Postman. So let's go to Postman, and let's clone this, duplicate, and we'll call it user service update user, and this is going to be a put, and the URL is going to need the ID of the object that you want to change. Yes. Yeah, no, save actually can, if you've changed something, right, it'll modify, it will only save and update the only field that you modified, right? But here I didn't want to arbitrarily change one field or another field, right? You could just modify just one field, right, and provide a function that only changes the username, perhaps. Right? I just wanted to wholesale, provide, depending on the JSON object that came, just change one or another. But yes, save is smart enough to know that if a field change or not, right, it only update that one field. Yep. So anyway, so let's change Alice. I think Alice's ID is 1. Let me verify. Alice indeed is ID 1, and the body we're going to change the first name. We'll change to Alicia. Okay, so let's do we return something? I forget. Here in the updates, in the user service, yes, we do return the user after change, and the setter, this method, I thought, why are you not seeing it? Is undefined. Is it? It's there. It's right there. What? Okay. All right. It was not updated. All right. So let's restart the server. Did I restart the server already? I forget. And let's do a put on it. Okay. Let's do a put, and let's send the put. And there we go. So notice that it did fetch the object after it's been updated, and the first name indeed has changed. Right. So we can go back and verify in the database and refresh this, and notice that Alice now has changed to Alicia. Okay. Awesome. So we've been able to update. The other type of updating that we would like to be able to do is be able to perhaps remove the user, like delete a user. So let's map that. Delete mapping. So let's go to our user service, and let's add a delete. Oops, copy, and the delete mapping. There it is. So let's import the delete. We're going to read the user ID, and again, notice that we have a .delete that is implemented by the boilerplate user repository, and we're parsing the user ID from as a path variable. Again, let's restart this, and from Postman, let's duplicate this. Let's duplicate this here, and let's change it to be a delete user. So let's see, this would be delete user, delete, and we want to remove, let's remove Alice. So let's send this, and let's verify in the database that indeed she is be missed. There it is. So Alice is done, right? So we are able to do our last types of updates. Do an update, retrieving the instance and updating its one of its fields, or removing entire record from the database.